In this question, we are given a utility function, investor risk aversion factor A, 3.75, and return distribution of the risky assets. We are asked to find the optimal dollar amount to invest in risk-free securities. Basically, we need to calculate Y, the optimal weight in risky assets. Before I go over Fox's solution, I want to show you my approach first. It's a lot more time efficient. Let's get started. The formula for Y is expected return of the risky portfolio minus risk-free rate divided by A times sigma squared of the risky portfolio, or the variance of the risky portfolio. But the formula only works for the standard utility function. So we need to rewrite the given utility function in the standard form so that we can use the formula for Y. First, on the given utility function, we multiply both sides by 2, and we got 2u is equal to expected return minus 1.4 times 3.75 times sigma squared. I put individual numbers in its own cell so that we could use those numbers later in cell formula elsewhere. Next, we need to have 0.5 in front of A. So we need to adjust A to achieve that. The adjusted A is 1.4 times 3.75 divided by 0.5, and we got 10.5. Now let's type out the formula for Y. I recommend typing it out for partial credit, just in case we make a mistake on the calculation. Don't bother using math symbols. For example, for sigma, just type sigma. The numerator is the risk premium, 10%, which is given. For the denominator, it's not given, but we can use the variance formula to find it. Let's type out the formula. Once again, don't bother use summation symbol, just type the word sum over. This is pretty clear to the graders. On the actual exam, the sigma would most likely be given. For now, let's calculate it on Excel so that we can practice this kind of calculation on Excel. It comes in handy later on, especially for section C and D. First, we need to calculate the expected return of the risky asset. And we could just use Excel sum product function. Now let's cut and paste the variance formula below the expected value. The first item in the summation is the probability, 80% times 15% minus expected return 14.25% squared. Make sure we use absolute value reference for the expected return by putting the dollar signs in front of the cell letter and row number. Normally, we could use shortcut by pressing F4, but this shortcut would not work on the actual CBT Excel environment. Now, drag down the formula and sum them up. We got sigma squared equal to 0.011569. Finally, we can calculate Y. Risk premium divided by A times sigma squared. And we got 0.8232. I will show you why we can ignore the factor 2 here. when we go over Fox solution. The question is asking for the dollar amount invested in risk-free securities. The final answer is 50K total investment amount times 1 minus Y, which is 8,838. Now, let's go over Fox solution. Similarly, we first calculate expected return of the risky asset, 14.25%. Next, we need to calculate the risk-free rate, which is 14.25% minus the risk premium of the risky asset, and we got 4.25%. Let's set up the equation for the expected return of the complete portfolio. Risky portfolio expected return 14.25% times Y plus risk-free return 4.25% times 1 minus Y. And we can simplify it to 4.25% plus 10% times Y. Next, we calculate the variance of the risky asset, which is 0.01157. Now we can compute the variance of the complete portfolio, which is the variance of risky asset, 0.01157 times Y squared. Now we can set up utility function in terms of Y. 0.05 times expected return of the complete portfolio we calculated here minus 0.7 times A, 3.75 times the variance of the complete portfolio, and we can simplify it. The second step is to take derivative of the utility function up here. du dy is equal to 0.05 2 times the constant, which is 0.0607 times Y, and we set it equal to 0. Let's pause here a little bit. Recall in the first solution, we would write the given utility function as 2u equal to the standard utility function format. Taking derivative of 2u, it would be 2 du dy, and we set it to 0. Divide both sides by 2. It becomes du dy equals 0. That's why we can ignore the factor 2 in the first solution and use the standard formula to find y. Now let's go back to Fox solution. Now we can solve for y, which is 0.05 divided by 0.0607, and we got 0.8232, which is the same answer that we got in the first solution. Finally, the dollar amount invested in risk-free securities is 50K times 1 minus Y.